Hi everyone. In this particular video, we are going to cover first three problems of Leetcode weekly contest 403. So let us quickly jump into the very first problem. Here you should be able to see this problem, minimum average of smallest and largest elements. So it is mentioned you are given a floating point array. You are given an array of floating point numbers, averages, which is initially empty. So the array is empty, you have to build it. You are given an array nums of length n, where n is even. So you repeat the following procedure n by 2 times. Remove the smallest element and the largest element from the nums and add min element plus max element by 2 to averages. Okay, so you have to do this particular process. So the first example is given 7834. I'll quickly note it down. 7834 15 13 41. So 15 13 41. So here what you can do is you can sort the array, because what you have to do is you have to pick the biggest and the smallest element, and then you'll remove both of them, and there is one average array which is going to be of floating point numbers. So you'll find 15 plus 1 by 2, whatever value you are getting, you'll add it here. So it is 8, so 8.0, because of floating point number it is going to be there. Okay, similarly, so when these are removed, next time the next smallest value is 3 and greatest value is 13. You'll do the same again. I think the sum is going to be 16, 16 by 2. So 3 plus 13 by 2 is going to be 16 by 2, which is coming out to be 8. Since it is a floating point number, it is going to be stored as 8.0. So you'll repeatedly do this process n by 2 times, because n is even. So in n by 2 times, you'll be able to cover all the elements. And since we in every step we are focusing on the smallest and the biggest value, it's better to sort them in increasing order. So once the array is sorted, you will have something like this: 1 3 4 4. Then we have 7 8 13 and 15. So this is going to be the first set of elements which you remove. This is going to be the second, this is going to be the third, and this is going to be the fourth set of elements. Because number of elements are 8, you will perform n by 2, 8 by 2, which is 4 operations. So now this problem becomes very easy. You just have to sort the array. After sorting the array, you'll have two pointers. One is going to be at the start, one is going to be the end, because your goal is to select the smallest and biggest elements. Once you select them, you'll find the average, which is smallest plus biggest by 2, and add this value in the third array. Or what you can do, you can just maintain a variable where you'll do the comparison and keep updating the minimum. Okay, minimum average. So let us code it down. So I'm using C++ for coding it down. Let us say answer variable I'm taking. I'll return my answer. Okay. Now what I can do is I need to sort my array. So I'm sorting my array from beginning to end. So once the array is sorted, elements are arranged in increasing order. Once they are arranged in increasing order, I have to take two values, I and j, and j should be equals to the very last index, because that's where the biggest element is present. I is pointing at the smallest element. Now you will use a while loop. So there should be this condition, I should be less than j. Okay, because your smallest value cannot be greater than the biggest value. So since the array is sorted, you don't want to go to any element which is already used, so this condition is a must. Now what you have to find is you have to find the average that you are getting. So let us convert everything into double. So I'll say the smallest value is present at ith index, the biggest value is present at jth index, And here I can also use the number from which I'm going to divide, that is going to be 2. Now the average that you are going to get is smallest plus biggest divided by div. Okay. Now here, if I is 0, it means this is the very first pair that you are taking out. So here you will initialize directly whatever average you are getting, you will assume this is going to be the smallest. Okay. If I is not 0, then you have to do the comparison and you will find, or you will store the smallest value in answer. So smallest value between the average and your current answer value, it will compare both of them and will store the minimum. Because in problem statement we have to find the minimum average or minimum value in averages array. Okay. So now what you are doing is, after having that pair, you'll move on to next pair. So you have to move your I to next by doing increment operation of 1, and you have to decrement j. So increment decrement simply means from 1 you'll go to 3, from 15 you'll go to 13. Because once 1 and 15 are removed, 3 is the smallest, 13 is the biggest. Okay. So this goes on, and now what we can do at the end, we can return the answer. That's it. Now if I try to run the code, let's see if we have made any silly mistakes or not. So it is passing all the test cases. Now we can move on to next problem. So this problem is, as you can go through this, find the minimum area to cover all the ones. So there are two parts. This second problem and fourth problem are like almost similar. The change of operations are there. Some different operations you have to perform in the fourth problem. So here the problem is very clear. You have to find the minimum possible area of rectangle which is going to cover all the ones. Okay. So now the logic here is, it's more like an implementation problem. Everyone, I'm assuming, should have got the logic for this. So it's like this. If you have a matrix like this, and suppose randomly ones are present in certain manner, so here what you are interested in is, you are interested in knowing these points, like what is the smallest column where one is present, what is the biggest column where one is present, smallest column, biggest column, because your rectangle should cover all these columns because ones are present there. Similarly, you need to find smallest row and biggest row. So if I do the numbering, so these are rows and these are columns. Okay. So what you can see here is, the smallest row where 1 is present is 1. The biggest row where 1 is present is 4. Similarly, the smallest row where column is present, sorry, smallest column where 1 is present is 0, and biggest column where 1 is present is 3. So now this is going to give you this height. So your rectangle need to have at least this much height. Then only these ones are going to be covered. Okay. And this is going to give you the width. So your rectangle need to have at least this width, that then only you'll be able to cover all the ones from the smallest column to the biggest column. Okay. Now how you can find the height? Height is nothing but biggest row minus smallest row plus 1. And width is nothing but biggest column minus smallest column plus 1. So both of them comes out to be 4. So you have length also 4, you have width or breadth also 4, and area is length into breadth, which is coming out to be 16, and which is correct also. You can see this particular rectangle you require, this rectangle, And the dimension of this is there are four rows and there are four columns. So area is going to be 16. So we are going to do the same. Smallest of row and smallest value of column. Smallest row, smallest column, then smallest, biggest row, biggest column. We'll initialize all of them with 0. Like we can initialize them with 0. Just declare them and let us initialize them with 0. Or we can initialize them with -1. So if we want to check if the values are already updated or not. Okay. Now what you can do is you will simply go through your grid. So I equals to 0, I is less than n. Let us find how many rows are there, which is grid dot size. And let us also, I think, is it visible? Let's see the column also. So grid 0 dot size. So that's how we can find number of rows and columns in a 2D matrix, 2D vector in C++. So we are going through the rows. We have to go through our columns. If this value is 0 present at cell ij, we don't have to perform any operations there. Else if it is 1, then there are case. If SC is -1, it simply means this is the very first one that you are finding. So you update everything. Smallest row equals to biggest row, which is equals to I. Because this is the only cell which you found till now. So you are assuming you are updating your smallest and biggest row values here. And smallest column and biggest column also equals to J. If this is not the case, then you'll compare. So if in smallest row what you want, so SR equals to minimum value of whatever value is stored in smallest row and whatever value of I you are having. In biggest row you want to store the maximum value. So maximum value of biggest row and the value of I. Similarly, smallest column you'll focus on J value. Similarly, for biggest column, you'll still again focus and try to find the maximum between the biggest column and the J value. Okay. So once you have the smallest row, smallest column, biggest column, you'll find the length, which is biggest column minus smallest column plus 1. Or this is not length, this is width basically. This is width or breadth, you can say. It is, let's write it as breadth. And width length is going to be biggest row minus smallest row plus 1. What you have to do is return the area. Area is L into B. So you'll return that area. Let's see if it is working or not. It should work. What we are trying to do. Okay. So we are getting 4 in this case, but expected answer is 1. So we did some mistake here. Smallest row, biggest row minus smallest row. Smallest row, biggest row equals to I. Smallest column, biggest column equals to J. Okay, that is correct. This is also correct. Which test case it is? 0010. Yeah, you don't actually need anything here. So let's see what all the values of smallest column, biggest column is, and followed by, it should be like this, smallest row and biggest row. Mhm. Okay, it is 0101. We messed up something. Okay. Oh, here. Oh, I think the line is the mistake is in this line. So if this value is 0, then you will ignore this cell. Okay. So we were getting wrong values because of it. So what we are doing, if it was 1, we were ignoring, and if it was 0, we were considering. So silly mistake. Okay. So whenever the grade contains 0, you don't have to perform any operation. So I said that, but I didn't perform that operation. Yeah. So now it is passing. Now let us move on to third problem, which is very good problem. Yeah. Let's go through it. I hope this is visible. Yeah. So problem name is maximize total cost of alternating subarrays. Okay. So alternating subarrays. What is given in problem statement is you are given an integer array nums, the length of arrays and cost of subarray. So they have defined some cost function. Cost of subarray where L and R are valid indexes is defined as nums of L minus nums of L plus 1 plus this and so on. So it is basically minus 1 to the power R minus L. Or those who are unable to understand this, it's basically alternating array they are forming. Like here the first value is going to be positive in subarray, second value is going to be negative, third value is going to be positive, fourth value is going to be negative, and so on. Okay. Now what our task is to split array nums into subarrays such that total cost of subarray is maximized. So we need to maximize the total cost. Okay. Now ensuring each element belong to exactly one subarray. Okay. Formally, if nums is this. Okay. So yeah, it's similar to if you have solved this problem where you have to split your array into what I can say k groups. Okay, parts. It's similar to that. They already mentioned, but if they have not mentioned, those who practice problems like this, they should be able to catch up. Return an integer denoting the maximum total cost. Okay. If no nums is not split into subarrays, if k is 1 means number of parts are 1, total cost is equals to cost for 0 to n minus 1. Okay, makes sense. Let's do how they have done the splitting here. 1 minus 2, 3, 4. So first of all, what you have to do is you have an array. You can split them into multiple subarrays. Okay. Suppose this is one of the subarray. Then this is one of the subarray. Then we have another subarray, suppose. Then we have another subarray. So we can do multiple splitting. Okay. But what is the goal? We want to maximize the cost. Maximize the cost. And how the cost is defined? If there is a subarray of suppose 1, 2, 5, 6, something like this is there. So in this, the very first element is going to be positive, next element is going to be negative. After that, next element is positive, then next element is negative. So what is the cost you are getting? 6 minus 8, which is minus 2. Okay. So that is how it is defined. Now, one thing which you need to understand here is you are given the authority to split your array into disjoint subarrays. Okay. So now it also means you have choices available, like where you can put the splitting. You can take this subarray and then perform the split. You can have this subarray and then perform the split. So you have choices. You have options. So whenever you have choices and options, you can use recursion. Okay. Okay. So whenever you have choices given, it's better to use recursion. Using recursion, you can explore all the options and find the optimal one. Now, logic for recursion here is how we use recursion. So for recursion, there are certain steps which you need to follow. First step is you have to assume you are at some random state. You are at some random state. Okay, before that, another thing is important. What you are expecting from your recursive function. What you are expecting from a recursive function. Okay, this part is very important because in recursion, what happens is you focus on any random state, you do all the required operation for that particular state, and recursion take care of all the remaining cases. So it is very important what you are trying to achieve from your recursive function. You should note it down before even writing the recursive solution. Okay, and you need to have a faith that when you call that recursive function, it is going to give you the same result what you expected. Okay, now next steps are you have to assume yourself to be present at some random state. So in our case, what can be the random state? Okay, when an array is given to you, usually we move from left to right or from right to left. You can move in any direction. Suppose we are moving from left to right. Okay, so obviously we can assume at some random index I we are present at. Now, what else parameters are required? Now, you can think here is when you are present at any index I, you have two options. What are those two options? Those two options are either you can take this ith value in your current subarray, whatever be your current subarray, or perform the splitting. You cannot skip. Okay, perform the splitting. I'll explain with an example here. If we have something like this 1 2 3, so you took the first element, and after taking you are going to the next element, so your subarray contains 1. Now where you are present at, you are present at element with value 2. Now what option you have? Either you can have a subarray like this, or you can perform a splitting. So this subarray is closed, and once you perform the splitting you will have a new subarray where you're starting with 2. 2 is part of that new subarray, and from there you can go on to find uh, core for remaining indexes and all. So two options you are having: either you can make 2 part of your current subarray, or you can do the splitting. Okay, so when you are performing these operations, like when you are considering the ith value in your current subarray, then you have to add its value so that you can get the score for that subarray. Now for adding the value, one thing that is important is like what should be the sign. Observation that you can make from here is if you have 1 2 3 4 in your subarray, this is positive. This is going to be negative. This is going to be positive. This is going to be negative. So 1 minus 2 plus 3 minus 4, something like this. So when you are present at 2, how you will realize you have to use a negative value. Or one more thing, what I can say is if we consider zero based indexing for these subarrays, so one thing I can observe, all the even place or even indexed values in your subarray are going to have positive sum. All the odd indexed values you have are going to have negative sum. Okay, so this you can see. So you need a variable that will tell you the parity. Parity in the sense currently whenever you are visiting to any element or going to any element, if you take it at what position it is going to be, it is going to be at odd position, it is going to be at even position. So if it is at even position, so we are talking about like if you have this subarray, if you do the indexing, 1 is present at index 0, 2 is present at index 1, 3 is present at index 2. So 1 and 3 are present at even indexes. So they have positive sum. So if you maintain a parity variable also, so you will be able to know you need to add a positive value or you need to add a negative value. Okay. So here one more parameter which you require is what is the parity, and anything else you require your array. Okay, these three things you require. And whenever you are doing the splitting, it is always going to be positive because this is the very first element which is present at index 0. So it is always going to be positive. So for this part, when you are considering ith value to be part of your current subarray, you require this parity thing. Okay. Now, whatever we discussed till now, let us try to code it down, write a recursive solution for us. So I'll declare a recursive function which is going to give us maximum score. Okay, I didn't talk about what I'm going to expect from this recursive function. I'm going to expect the maximum score. Okay, whatever constraints are there, according to the constraints, what is the maximum score I can get for given constraints. That is my expectation, and I will believe that this recursive function that I'm creating is going to do the same. So we have two variables, index I and parameter, no, sorry, not parameter, parity in our parameters of recursive function, and we also require our array. Okay. Now remember one more tip that I can give you here is when you are moving, when you have a function like this where you are moving from left to right, going from left to right. So base condition you can always choose like this. Whenever your index is invalid, so index is invalid, in that case the maximum score you can get is 0. Okay, why I have added greater than equals to, just to cover all the cases. Here we are doing a jump of 1 only, like from index I we will go to I plus 1. But there might be problems where you are moving from left to right, from index I you can go to I plus 2 or I plus 3. So base condition is whenever your index becomes invalid, you have to stop there. You have to stop your recursive calls. Okay, whenever index is invalid, stop. So greater than equals to will cover all the cases. Okay, so in most of the problem this works. In some of the problems you might have to make some changes. Okay, now coming to this, what options you have? So option one is, so when we are considering ith element to be part of current subarray, when we are doing that, so we will have this much value because ith element value is equals to nums of I. If the parity is 1, it means this value is present at odd index, and as we discussed, so somebody who is present at odd index we have to make them negative. So I am multiplying this with negative 1. I use this LL because of long typecasting. Okay, now you can do the recursive calls. So you are done with ith index, you have considered this. Now for remaining index, what maximum score you can get, you'll use the recursive function. You'll go to the next index, and this time parity is going to be this. Parity plus 1 mod 2. Okay, that's how it is. Like if parity is 1, 1 means odd index. Now 1 plus 1 is going to be 2. If you do mod with 2, you'll get 0, which implies even index. If parity is 0, 0 plus 1 is 1, 1 mod 2 is 1, which implies odd index. So we are doing parity plus 1 mod 2 for the next element, okay, next index. And this, okay. So this is option 1. What is option 2? Option 2 is when we are splitting. We are splitting. We are making ith element to be part of new subarray. In that case, This is going to have value nums of I. Okay, there is no need of checking for parity here because this is the very first element which is present at index 0 if you consider indexing. So the cost that you can get is you'll use the recursive function again for finding the same for remaining elements. You'll go to the next index again. This time you can write parity to be 1 because this is your first element which is present at index 0. Now next element will be present at index 1 which is odd. So we are passing 1 directly here. Okay. And nums. So you got two options. Here it should be OP1. Here also OP1 option 1. So from both the options you will choose the one which is giving you maximum score. Okay. Now let us try to call our recursive function, and whatever value we'll get from the recursive function will return it. So we are starting from index 0. Initially the parity of the very first element will be 0 only, and we'll pass our array as the parameter. Now let us see if this is working or not. So it is working. We are able to write the recursive solution. I think this make sense. Now you can analyze. This is for base condition. Index is not valid. The maximum score you can get is 0. Option 1 is when you are considering ith element to be part of your current subarray. Based on the parity, you have to change the value. If element is present at odd indexes in subarray, it means odd indexes. Again, don't get confused. It's like this. If you have 1, 2, 3, 4, you may argue that if one you are having one subarray and you are doing a splitting at this point, or 2 is present at index 1, but why you are taking plus 2 as the score? Because this element 2, the subarray, suppose the subarray that we are forming is 2, 3 in this case, this 2 is the first element. So according to this subarray, you have to assume this subarray as a array, a different array. So in that array, if this 2 is present at odd index, you'll use negative. If it is present at even index, you'll use positive. So here if I write the indexing for elements of this subarray, this only, don't match this and this entire array. So 2 is present at index 0, 3 is present at index 1. So what I did, I am assuming this subarray as a different array. Okay. So in that perspective, I am saying that. Okay. If they are present at odd places in subarray, then you have to use negative sign. If they are present at even places, so places are starting from 0. Okay, so your value are going to be positive, and based on making the changes, you'll use your recursive function for finding result for remaining indexes or elements. And similarly, option 2 is where you are performing the split operation. So in split operation, your value is obviously going to be positive because this is the element present at index 0 of its subarray. Okay. And you will do the same. You'll use your recursive function. So recursion works as a magic. Whatever you are assuming, it works. If you do right at random state. So at index I, we are performing all the operations correctly. So for all remaining indexes, recursion is taking care of them. But if I try to submit this, it will give me TLE. The reason is constraints. If you look at the array size can be up to 10 to the power 5, which is very big. And the time complexity of this particular problem is 2 to the power n because for every index you have two options. So 2 into 2 into 2 into 2 n times is 2 to the power n. So to get rid of this, we use a technique known as memoization where we can store the result of the states. Usually we use arrays for doing this, but you can use hash map and map also for the same. And memoization plus recursion is known as DP. So very standard name for memoized array can be DP. You can name it anything. And here the array is going to have what dimension of array you are going to have depends on number of changing parameters. Here index I and this parity, these two things are changing. So what you are going to do is we are going to create a static array where the size of first or row I can say is going to be 10 to the power 5 plus 1, because the maximum value of index can be up to 10 to the power 5 minus 1. Okay. And for parity, we require two size. So this we are able to create. Okay. This is well enough to equip any array according to the parameter that is given. Okay. So we are creating a static global array kind of thing. Okay. I'll not call it global. It is this particular array is accessible inside this function. Okay. You can create an object and access from anywhere. But yeah. So it's a static array, and dimension you can check. The maximum value of I is going to be within this range. Whatever array you are creating is going to be enough for storing that, and even for the parity, it is going to have value 0 and 1. So which can be stored in this. Okay. Now, how memoization works is, before computing, you check you have result or not. Like, the goal of memoization is compute once and use multiple times. So you have to compute any result for only one time. Okay. Here one more thing is there. We fill our memoize array with some default value. Okay. So default value can be any value which cannot be achieved by your recursive function. So the minimum score of this recursive function is 0. So we are taking minus 1, which is not achievable by this recursive function. Okay. Now, why we fill them with a default value is just to check if, for the following constraints, if the value is not equals to the default value, it means we have the result. We already computed the result and we have the result. So we will return the result directly. If the value of the following parameter or the state is not equals to default value, because minus 1 was the default value, it means you already have computed and stored in this array. So let us use the result. Else you will compute, and before returning the result you will store. Okay. So here first you are storing, then you are returning the result. So in future, obviously, the result, whenever you are computing result for any of the state, it is never going to be equals to minus 1. So if the value is not minus 1, it means you computed. So whatever you computed, you are returning it. Okay. Anytime you'll compute uh, the states or random states, the values are going to be the same. Like for index I 0, parity 0, your result, whatever you will get, it is going to be same. Even you compute 10,000 times. So it's better to store it and use it. So now if we try to run on this test case where we got TLE, it should pass until we made some silly mistake. Now it is passing in 0 microsecond. Now let us submit this. It is going to be accepted. Yeah, it is accepted. So that's all. In this particular video, we covered the first three problems. This one was very good problem. You have to focus on identifying how you can identify when to use recursion and all, and when to use memoization. Okay, memoization always helps when you have overlapping sub problems, and also when you want to reduce or make your program more efficient. That's all. Thank you.